Good afternoon, children. In this chapter of nitric acid, we shall today study about the chemical properties. Okay, so chemical properties of nitric acid. The first chemical property we are going to talk about is its stability, right? What do we know about the stability of nitric acid? Pure nitric acid is unstable to heat or sunlight. Okay, what did I say? Pure nitric acid, it is unstable to heat or sunlight, right? And therefore it easily decomposes to give nitrogen dioxide, which is a reddish brown color gas, plus water, and colorless oxygen is also given out, right? Therefore, in the laboratory, the nitric acid stored in the bottle, it turns yellow. Why? Because of the dissolved nitrogen dioxide in the HNO3 acid. Clear? So, we can also say that in the presence of sunlight, nitric acid decomposes even at room temperature. And therefore, this nitric acid, which is kept in the glass bottle in the laboratory, it is always yellow in color. Next, we are going to talk about acidic nature. What do we know about acidic nature of this nitric acid? Yes, it is a strong monobasic acid. Now, why do I say strong monobasic acid? Because HNO3, when decomposes, what does it give? It gives us one hydrogen ion and a nitrate negative ion. This hydrogen ion, it cannot exist like this, so it combines with the water molecules that are present in the air and forms hydronium ion, right? So what can we say? That this nitric acid on decomposition gives us one hydronium ion, and therefore it is what? It is monobasic acid. Clear? Is this point clear to all of you? Then what do we know about the indicators? Like blue litmus turns red, your methyl orange turns pink, and your phenolphthalein remains colorless. Further, moving with some more acidic properties of nitric acid. So let's talk about the first acidic property. Could be like a reaction with the alkalis. Okay. So we all know that acids, when combined with bases, what do they form? They form salt and water. Thus, that could be first example for you. Let's take calcium oxide and nitric acid. So what is it going to form? Base and acid. What is it going to form? CaNO3 whole twice plus H2O. Salt and water is formed. Another example could be like K2O plus HNO3. What is this going to form? This will form KNO3 plus H2O. Salt and water is formed over here. Similarly, zinc oxide plus HNO3. What can this form? This will form ZnNO3 whole twice plus H2O. Okay. Then these are your bases. Hydroxides are also termed as bases. So we can take like NaOH when treated with HNO3. What are we going to obtain? We shall obtain NaNO3 plus water. Okay. Take another example. Another base like CuOH whole twice. When combines with HNO3, what is it going to give us? It will give us CuNO3 whole twice plus H2O. Right? So the first acidic nature of nitric acid is clear, that the bases, when they react with the acid, they form salt and water. Now what kind of acid are we going to talk about over here? Just now I am dealing with dilute HNO3. Okay. The dilute HNO3 always exhibits acidic nature. So we are discussing about dilute HNO3. Now further, let us talk about certain carbonates and bicarbonates. Okay. Carbonates and bicarbonates, they also, when treated with the acid, they release or they give out water and carbon dioxide along with the salts, right? So let's take an example like Na2CO3 when treated with HNO3. What is it going to give us? It is going to give us NaNO3 plus CO2 plus H2O. Clear? Another example could be like ZnCO3 plus HNO3. What is this going to give? Yes, ZnNO3 whole twice plus CO2 plus H2O. Okay, a bicarbonate like let's take NaHCO3 plus HNO3. This is going to give us NaNO3 plus H2O plus CO2. Now, one important question comes over here. What do you observe? What do you observe when sodium carbonate is treated with dilute nitric acid? So here I do not expect you to give me the reaction. You write the reaction, very good, very nice. But the question was, what do you observe? So for carbon dioxide, please write brisk effervescence. What do you observe? Brisk effervescence which turns lime water milky. I hope this is clear. Another question could be, what do you observe when nitric acid is added to sodium bicarbonate? So brisk effervescence of carbon dioxide is observed which turns lime water milky. I hope this is clear to you. Okay, we next come to the third acidic property of nitric acid, that is, what about the action with the metallic sulfides and bisulfides. So let's take few examples like Na2SO3 plus HNO3. Now always remember, these sulfides, they give out sulfur dioxide gas. Okay, so here it is going to form NaNO3 plus SO2 plus H2O, right? Another example could be like CuSO3 plus HNO3. It is going to give you CuNO3 whole twice plus SO2 plus H2O. Let's talk about one bicarbonate. So, bisulfite. So, let's take NaHSO3 plus HNO3 on heating. What is it going to give us? NaNO3 plus SO2 plus H2O. Now, balancing you can do on your own later on. Okay. So, once again, what do you observe when sulfur dioxide gas is released? Burning sulfur. Smell of burning sulfur. I did not ask you the further test for sulfur dioxide. Remember, first what have you to write? It smells like burning sulfur, and further you can talk about the different tests of sulfur dioxide gas. Okay, the next one could be the next kind of acidic nature of nitric acid could be when nitric acid is treated with metallic sulfides. Okay, so let's talk about a sulfide like FeS when treated with HNO3. What do we observe? Yes, rotten egg smelling gas is given out. So what is it going to give you? It will give us FeNO3 whole twice plus H2S gas. And what do we know about this H2S gas? Rotten egg smelling gas, right? Another example could be like Na2S when treated with HNO3. Okay, so this is going to give us what? NaNO3 plus H2S gas will be given out. The rotten egg smelling gas will be released, right? So these were some of the reactions which are acidic in nature. Now one more reaction I had taught you in HCl chapter, that is when the metals, they are dropped in the acid, they release hydrogen gas. Do you remember? And there I had told you that they also give you brisk effervescence. But here nitric acid does not react with metals. to release hydrogen gas. Why? The reason is because they are good oxidizing, because it has good oxidizing property. Clear? So after this I will explain you the next property of nitric acid, that is its oxidizing property. So first thing we studied about its stability. The second point about it was about its acidic nature. The third point that we are going to study is about the oxidizing nature of nitric acid. Okay, I hope till here everything is very clear to you. Its oxidizing property. Clear? Now, this nitric acid, it oxidizes most of the non-metals. Okay, it also oxidizes metals. It also oxidizes organic compounds as well as inorganic compounds. So in today's video we are going to finish off all the reactions of nitric acid which exhibit oxidizing property, that is nitric acid treated with non-metal, metal, organic compounds and inorganic compounds. Is this very clear to all of you? Now, nitric acid itself undergoes reduction and therefore it shows oxidizing nature. Is this point very clear? The substance which gets reduced is a good oxidizing nature. Okay. Thus over here nitric acid itself undergoes reduction and so it forms different products. What are those different products? The products could be like nitric oxide or sometimes NO2 is also given out. All this depends upon the concentration of the acid as well as the temperature of the that is taken during the reaction time. Clear? So now these oxidizing properties which we find in nitric acid is due to what? It is due to the formation of nascent oxygen. So this nitric acid on decomposition gives out nascent oxygen, due to which the oxidizing property of nitric acid is exhibited. Right? So over here we will see how nitric acid, due to this nascent oxygen, oxidizes non-metals, metals, organic compounds and even inorganic compounds because it itself gets reduced. Okay, so before we begin with this, let us first understand two important reactions over here. What? When HNO3, it is concentrated. Okay, so this on heating will give us what? It will give us nitrogen dioxide gas, water and your nascent oxygen. This is very important. And if we use dilute nitric acid, then this is going to give us nitric oxide, water and nascent oxygen. So now what are we going to study? If we study about concentrated HNO3, always remember that nitrogen dioxide gas will be given out. Okay. And if we are using dilute acid, then what will be given out? Nitric oxide will be released along with these nascent oxygen and water will be formed. So now let us start to understand the oxidizing property of nitric acid with respect to non-metals. Okay, so the first one could be let's talk about with non-metals. So over here, if we take carbon and treat with HNO3, okay, if I take carbon and treat it with HNO3, what kind of HNO3 am I talking over here now? I am first going to talk about hot concentrated HNO3 using hot concentrated HNO3. Clear? What am I going to use over here? I am using hot concentrated HNO3. So hot concentrated HNO3 is going to give out what? NO2, and it is going to release this nascent oxygen, and this nascent oxygen is going to oxidize or carbon, right? So it will oxidize carbon to carbon dioxide, And what gas is given out? NO2 is given out and water is released. Balancing you can do on your own later on. Okay, I hope the reactions are clear to you. Take another non-metal like sulfur. When treated with HNO3, so sulfur over here will get oxidized, right, because of the release of nascent oxygen. So what is it going to form? It will form H2SO4 plus, because I'm using hot concentrated nitric acid, so it has to form NO2 plus water will be formed over here. Similarly, if I use phosphorus with hot concentrated nitric acid, it is going to form phosphoric acid, H3PO4 plus nitrogen dioxide gas is given out and water is also released, right? Next we come to with the hot concentrated nitric acid, how does it react with the metals, right? So metals like say copper, when is treated with hot concentrated nitric acid. With hot concentrated nitric acid, what is it going to give you? It is going to give you copper nitrate. Okay. Now hot concentrated means it has to give you NO2 and H2O. Fine. Take another example like zinc when treated with hot concentrated nitric acid. What is it going to give? It is going to give you ZnNO3 whole twice plus NO2 plus H2O. Okay, so are these clear to you? Now, over here, I would also like to compare this hot concentrated nitric acid with dilute nitric acid, or dilute cold nitric acid, to show you the difference between the reactions. So, here I am using your cold dilute nitric acid. Okay, and let me treat, this is the third kind of a reaction, and let me treat over here the same metals, copper and zinc. So what is the reaction that will happen over here? When copper is treated with dilute cold nitric acid, dilute cold nitric acid, so what it is going to form? Shows the oxidizing nature, that is, it is going to form CuNO3 whole twice plus what, according to a general acidic property, when a metal is dropped in HNO in an acid, it should form the salt and hydrogen gas. But here what happens? Here what happens? This H2 hydrogen is oxidized to water. Okay, and because it is dilute HNO3, so what is it going to form? NO. Now look at the difference between hot concentrated nitric acid treated with copper and cold dilute nitric acid treated with copper, right? The salt is the same, fine. Here water, hydrogen is oxidized to water, hydrogen is oxidized to water, but here nitric oxide gas is given out, but in hot concentrated HNO3, nitrogen dioxide gas is released. Now what do you observe? What will you observe over here? Reddish brown fumes can be seen. Reddish brown fumes are observed. Okay, let's take another example. Zinc when treated with cold dilute HNO3. Okay, with cold dilute HNO3, it will form ZnNO3 whole twice plus water plus, because it is dilute, so it is going to form nitric oxide. I hope till here it is very clear to you. Next we come to there are certain metals like manganese and magnesium. Okay, with 1% dilute HNO3, they can be treated with 1% dilute HNO3 to obtain hydrogen gas. Right? These are the only two metals. Only and only two metals which can give hydrogen gas, right? So over here I can give you one example like Mg when treated with HNO3. What is it going to form? It will form MgNO3 whole twice plus hydrogen gas is given out. Okay. Similarly, Mn when treated with 1% dilute HNO3, it is going to form manganese nitrate. Okay, manganese nitrate and hydrogen gas will be given out. But with other dilute nitric acid, it is not going to give you any hydrogen gas, whereas over here hydrogen has been oxidized to water. Clear? But there are few metals more which do react with 1% dilute HNO3, but still they do not give out hydrogen gas. So let's take an example like zinc. Okay, zinc, what did I say? Coal dilute HNO3, it is giving you this. But if this same zinc is treated with 1% dilute HNO3, okay, with 1% dilute HNO3, what is it going to form? It will form zinc nitrate plus water. Okay, because hydrogen will not be formed, it will get oxidized to water, and ammonium nitrate will be formed over here. There are some more. For example, iron. Iron can also react with dilute 1% dilute HNO3. Okay, so this can also form FeNO3 whole twice. Hydrogen will not be given out, it will get oxidized to water, and what else? Ammonium nitrate will be formed. So I hope all the differences are very clear to all of you. Okay, then these metals, you know what I'm talking about, like iron I discussed about, like aluminium, like cobalt. These are certain metals which when treated with HNO3, they show passivity. What do they show? They show passivity. Now you must be wondering, what is passivity? Passivity. So what is passivity? When these metals, they are treated with concentrated nitric acid. Here they were treated with dilute. So you can see this reaction. Okay, but the same metals like iron, aluminium and cobalt, right, when they are treated with concentrated HNO3, right, which is also termed as fuming, pure nitric acid I'm talking about, fuming nitric oxide, then they form a protective layer. They form a thin protective layer which forms an insoluble oxide layer, and it prevents the further reaction to take place. That means the reaction remains incomplete. That is called as passivity. So passivity, which metals show passivity with concentrated nitric acid? It can be aluminium, iron or cobalt. What kind of an acid is used over here? Concentrated nitric acid or fuming nitric acid is used over here. What is passivity? It is the formation of thin protective layer which is an insoluble oxide layer over the metal, which further prevents the reaction to proceed, right? But how can this passivity be removed? It is very easy, by rubbing off the surface layer with a sandpaper or even treating it with any strong reducing agents. Okay, is this clear to all? Next we come to, there are certain more metals, the noble metals, which are placed very low in the activity series. What are those metals? Like gold and silver. Do these HNO3s, concentrated nitric acid will react with them? No. So how are they treated then? They are treated with aqua regia. I have already taught you what is aqua regia. 3 parts of HCl, concentrated HCl, and 1 part of concentrated HNO3. They both combine to form aqua regia by volume. So what is aqua regia? What is it going to form? It is going to form nitrosyl chloride plus water plus what? What nascent thing is formed over here? Nascent chlorine is formed. Okay. Then these metals, they react with this nascent chlorine which is formed by the combination or the mixture of 3 parts of concentrated HCl and 1 part of concentrated HNO3 to form this chlorine, and hence here you will show that gold will combine with 3 parts of chlorine to form AuCl3, and even platinum with 4 chlorine nascent chlorine, it will form PtCl4. Right? Is this clear to all of you? Next we move to, we have done what? We have done the oxidizing property of nitric acid with the non-metals. We have done it with the metals. Now I'm going to talk about organic and inorganic compounds. Let's look at some of the reactions where inorganic compounds, when treated with nitric acid, what do they show? They also show oxidation over here. So let us talk about SO2, sulfur dioxide gas, to which we add little water to make it aqueous, and this aqueous solution, what is it going to form? Sulfurous acid. Okay, this when treated with your dilute HNO3. What are they treated with? Dilute HNO3. They will form H2SO4 and nitric oxide. Do you remember nitric oxide with dilute acid? Okay. Then another example could be like rotten egg smelling gas. When treated with nitric acid. Which nitric acid? Dilute nitric acid. It will give sulfur plus water plus nitric oxide will be given out. Similarly, if we take acidified FeSO4, how do we write acidified FeSO4? FeSO4 plus H2SO4. This is your acidified FeSO4 when treated with HNO3. What kind of HNO3 am I talking about? Again, dilute HNO3. What is it going to form? It will form Fe2SO4 whole thrice plus water plus nitric oxide will be given out. So these are some of the reactions with inorganic compounds. And last part in this video for organic compounds. How do organic compounds react with nitric acid? So concentrated nitric acid, it brings about oxidation and nitration of these organic compounds. Clear? What did I say? Here we are using concentrated HNO3. What do they bring about? They bring about either oxidation or nitration. Where? In what? In organic. Sorry. They bring about oxidation or nitration in what compounds? Organic compounds. Now is this very clear? So it oxidizes, like for example, if I take organic compound like sawdust, okay, it oxidizes this sawdust to carbon dioxide, water, and since it is concentrated nitric acid, so which gas will be given out? Reddish brown fumes of nitrogen dioxide gas will be given out. So what is the formula for your sawdust? It is C6H10O5, which can be number of times, could be repeated with nitric acid. What kind of nitric acid? I have already mentioned over here, concentrated nitric acid we are using here. So what is it going to form? It will form water plus carbon dioxide plus what gas? Because it is concentrated, therefore nitrogen dioxide gas will be given out. Right? This is your oxidation. This shows your oxidation process. So sawdust shows oxidation process with the concentrated nitric acid. Right? Another example you take like C7H8. What is this? This is toluene. Toul. This is called as toluene. Right? When this is treated with concentrated HNO3. Fine. What is it going to form? It is going to form C7H5NO2 whole thrice. What is this? This is called as TNT. This is an explosive. Okay. It is an explosive that is formed along with water. Right. So this is your nitration process. This is also termed as your nitration process. Right. With this, we finish off with the chemical properties of nitric acid. In next video, I'm going to come again with some tests of nitric acid and nitrates, and also will discuss about the uses of nitric acid. Thank you.